In Chapter 5, we're going to begin exploring numerical data. And we've spent quite a bit of time throughout this course earlier looking at categorical data. Now we want to kind of get into the other type of data that we sometimes collect in sports. And in this first section, we're going to talk about graphs of numerical variables. Before we do that, we want to review the types of variables that we can collect in statistics and how we can tell the difference between them. So you may remember that a variable is simply a characteristic or an attribute of an athletic performance. One type of variable is a categorical variable, which we know has outcomes that fall into categories. For example, if you collect information about the outcome of a game, whether it was a win, a loss, or a tie, those results would be placed into categories. So that would be a categorical variable. You also can collect numerical variables. Numerical variables have outcomes that take on numerical values that represent different quantities of the variable. For example, the score of the game would be numerical. You wouldn't just be interested in whether it was a win or a loss. You would want to know, for example, if the team scored 21 points or 85 points, depending on what type of sport you were looking at. Now, since this is a review, I would recommend that you pause the video and see if you can correctly classify each of these variables as being either categorical or numerical. All right, home jersey color is categorical. Number of fouls per game is numerical. Outcome of the game is categorical. Number of rebounds per quarter would be numerical. Time left on the clock is numerical. And points scored in the first half would be numerical. Now, numerical variables can be further classified as being either discrete or continuous. Discrete variables are variables whose values can be counted. For example, in a tennis match, if you count the number of first serves that are good, that would be a discrete variable. Continuous variables are variables whose values must be measured. For example, if you talk about the speed of a first serve, that would be a continuous variable because we would have to measure that maybe with a radar device or something. Another way that you can think about the difference between discrete and continuous is whether there are gaps in between the possible values. For example, if you're counting the number of first serves that are good, you might count that there are 12 first serves that are good, or maybe there are 13 first serves that are good. But it's not possible that you could have anything in between. You would not have 12.5 first serves that are good in a tennis match. So there are gaps between the possible values of that variable. With continuous variables, for example, there are not gaps. So, for example, you might have a first serve that is 90 miles an hour, and you might have a first serve that is 91 miles per hour. However, it is possible that you could have a first serve that is 90.5 miles per hour, or 90.25, or 90.00001. So, even though we might not be able to measure those because our measuring device isn't accurate enough, there are no gaps between the possible values of that variable. So, that's another reason why we say it's continuous. All right, let's identify each of these variables as either being discrete or continuous. The distance a quarterback throws a ball would be continuous. We would measure that with a tape measure or a meter stick. The number of the penalties in a game would be discrete because we would count those. Temperature at the start of the game would be continuous. That we would measure with a thermometer. The time left on a play clock, that would be continuous. We measure time with either a stopwatch or a clock. Number of fans in the stadium would be discrete. That would be something we would count. And the price of tickets to the game, that would also be discrete because we count money and there are gaps in between the possible values. Remember that measuring doesn't have to be with something like a ruler. It can be with a scale, a clock, stopwatch, a thermometer, any sort of measuring device. Now, the type of variable that you measure will determine how you display the data. We learned in earlier in the course that with categorical variables, we display them with bar graphs or maybe segmented bar graphs, or we use pie charts. With numerical variables, however, we will display those with either dot plots or histograms. And there are a couple of other types of graphs that we might use, but in this section, we're going to focus on those two. First, let's talk about dot plots. And we've seen these before because we've made dot plots when we've conducted simulations. But there, our dot plots were showing us sort of the result of many trials of some sort of experiment. Here, we're going to use dot plots just to display a data set. So dot plots work best for discrete numerical variables. They are also good for small-ish data sets. Generally, you don't want to make a dot plot with 500 dots on it. So you want your data set to be relatively small. Otherwise, it just becomes sort of time consuming. Also, side-by-side dot plots can be used pretty easily to compare two data sets. So we're going to make one of those. So we're looking at some data here where we have John who has two different types of putters and he wants to test whether short or long putters are more accurate. So we're going to make a side-by-side dot plot to show his results. The data that you're given is measuring the distance that the golf ball landed from the hole with each putt. So we have short putter and long putter. Notice we don't have the same number of data points, which is totally fine. And I've already given you a horizontal scale that's been labeled. And what we're going to do is we're going to separate this data and I'm going to do short putter distances together and the long distances together. And even though it's called a side-by-side plot, we make them kind of stacked on top of each other. So the name is a little bit confusing, but that's the way that we do it. I'm also going to draw in another horizontal line there to kind of separate my two data sets, but I don't need to label it with a scale because I want to use the same scale on both my data sets, and that way I can compare them. So I'm going to go through and make a dot for each of those short putts. So you'll notice that there were two putts with a short putter where he actually made it into the hole. So I have two dots here at 0. And then I had this one was at 5 and this one was at 8. And you're just sort of using your, best guess at where those points would be. But that kind of gives us an overall picture of what that data looks like. Now you can do the same thing with the long putters. And you'll notice that these distributions look pretty similar. Both of them had two putts where he actually made it into the hole. The short putter, we had a couple that were a little bit further away, but overall the shape is about the same for both. It looks very similar. And also the average distance is probably going to be about the same. It's probably going to be right about here for both of them. Now, this question is asking just to compare the distributions. And later on in this chapter, we will talk a little bit more specifically about how you can do that. But for now, we're just going to say that the distributions are very similar. The center and the spread of the data is about the same for both. So the center, we're kind of talking about the typical distance, and the spread is just kind of how clustered together the data is. And that's pretty similar for both. All right, there will be a second video for the second half of this lesson.